3, go. All right, everybody. Welcome, welcome, welcome to our pre-Thanksgiving mathletes. Now, how many of you know that turkeys are great mathematicians? Claire, are you looking at the screen here? I want everybody's eyes on the screen. Alexander, I don't know what you're doing, but I don't see you I only see your nose and above. Oh, hi, Isabella. I want to see everybody's face, chin to head in the screen. Beautiful job. And Rafa, I don't see your mouth, so you've got to either move yourself up or move your computer down. Either one is fine with me. Alexander, I can see you much better. Luke, you were perfect. Luca, John, Hannah, Claire, and I see Isabella's chair, which is a great chair. Now, I want to talk about turkeys. Turkeys are great mathematicians, and I'll tell you why. If I were multiplying the numbers, let's try the number 31 times 4. Well, do you know what a turkey would say to that? Any ideas?
No.
Okay, first of all, I want everybody to
Double.
I want everybody to unmute themselves right now. Cameron, Luke, and Claire. Okay? Go, John.
Well, I know what the answer is in like our language, but maybe it would be like gobble 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 or something.
Gobble, gobble, gobble is close.
Maybe
but
they would say like the answer, like the number.
Turkeys actually don't give answers. What turkeys do is they give strategies. So here a turkey would say
Double.
double. And can you double 31 2 times, please? Go.
62, 124.
24.
Double. What if a turkey were to do 52 times 8? What would the turkey say? Go.
Double.
Why would the turkey say 3 doubles instead of just 2? Who can answer that question? And when Isabella, can you get rid of the dog and get your pencil going? Because this is going to be a heavy pencil activity. It's not kind of a visual watch like a Disney movie, right? It's like you have to get involved in it, okay? So who can explain why 31 times 4 was just a double, but 52 times 8 is a double? Anyone have any ideas? Luca?
Because 4 is 1 times 2 equals 2, and then times 2 again equals 4. And then
Well, so what you went to say is that 2 times 2 equals 4.
Yeah.
Okay, and what about the 8?
So that's 2 times more than 4. So you have to double again.
So 8, guys, is 2 times 2 times 2. Okay? So that's why turkeys double 3 times with 52. Okay, everybody do it. First double is?
124.
104, go.
208.
200.
Go.
416.
Done. Now, you think advanced turkeys might be able to do something like 14 times 16? What would they do?
Double.
Because 16 is 2 to the 4th power. 16 is 2 to the 4th power. So let's do it, guys. Go. Come on. 28.
28.
40.
56. 112.
112. 224.
That's it, guys. So I want you to just have great respect for the dinner that will be in front of you tomorrow night. and think before that turkey was your dinner, that turkey might have been a great mathematician. Okay, so I kid you not. Every time I hear a turkey, I know everybody thinks they say gobble gobble. They don't. They say double double or double 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 or double 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 double. Oh, by the way, if you were multiplying by, let's say, don't say it out loud, by 1,024, how many doubles would that turkey say? Think about it. Don't say it out loud. 1,024. On three, 1, 2, 3, go.
Like 4?
No, it's way
No,
more.
sorry, not 4.
124?
Okay, let us explore this this is a very advanced turkey we're talking about. So we have to have a special piece of paper.
10.
How about 12 times 1,024? Now, some people might have gotten this. Are you ready? Fingers up, go. 2, 4,
4. Yeah.
2, 4, 8. Come on. 2. Everybody do it. Everybody do it. 2, 4,
4,
8,
16,
32,
32,
64, 128,
128,
256.
56,
512.
512,
1,024.
1,024. So the
Yeah.
turkey would have to do 10 doubles in order to do this. Now, guys, let's have some fun with this. Let's do 12 and we'll double it 10 times. Go. The first one is
12.
24,
24 is the first one. The
48,
next double is,
48,
keep going,
96,
96,
keep going.
192,
2,
That's the fourth one. Keep
3,000,
going.
384,
384,
184. That's the fifth one.
700.
780,
768.
68,
That is 6. We need 4 more.
536.
That is 7. Go.
God.
3,000. No,
3,072,
That's 8.
7,144,
6,144. That's 9. Go.
12,288.
Now, guys, everybody, if you have a calculator, or go get your cell phone or your iPad, let's do 1,024 times 12 and make sure that in fact it's 12,288 and see if this turkey was really a smart turkey or if this turkey was just a turkey.
I don't think.
I'm just gonna go get the laptop.
I think that's a good
I
idea.
say yes. Google's calculator says yes.
So what's the number?
1,288, yep. 12,288, yep.
12,288 is what the turkey got. That's what the turkey got. And what we got using our standard algorithm, okay, was also 12,288. So I put it to you guys that turkeys really know what they're doing. Now, we're going to use some of this turkey math to do some fun things today. The first thing we're going to do is we're going to talk about one of my favorite words. And I'm going to give, let's see, I want to give, I think I'm going to give Alexander a compliment. Alexander, I really like your headphones. Guys, is that a compliment or a compliment? Alexander, nice headphones.
I think
Or is it up here?
it's the second one.
Bottom.
The second
The
one.
bottom. I think bottom.
Bottom?
Bottom.
Okay. You receive a complimentary bouncy ball if you join this club. Is that complimentary bouncy ball the top or the bottom? When you
Top.
get something for
The top
free.
one.
Also, this one. Can anyone tell me the difference between the two words?
The E and the I.
Who is that?
David.
David, yeah. So raise your hand, buddy. So tell me what the difference is between the two words. Because this E and that E are the same, right? Go ahead, David.
So I think the one with the I means like, to give praise, like, oh, I like this. And the top one means like they go together, like complement each other.
They go together. Let's talk about the one on the bottom is fun. Isn't it nice to hear a compliment? My mathletes are incredibly nice. I have one of the most wonderful group of students on the planet. That's a compliment with an I. If I give you something for free, that's a compliment with an I. But I love compliment with an E. Who can give me a great use of that word? You can give it to me without math or with math. Luca?
The colors black and white complement each other.
I like that. I think black and white do complement each other. I'll give you one now. I think Mr. Kramer and Dr. Kramer complement each other. That's my wife, by the way. I would also say that Mr. Kramer and his best friend Craig complements each other. Can anybody else give me an example of things that complement? You got nothing? No things that complement? Things that go together well. Go for it, Luke.
Well, I mean, I've heard like at some restaurants, they'd say or like they'd say like here's a compliment or like at hotels they'll say sometimes here's a complimentary.
But that would be the E, right?
Yeah, no, that's the I, Luke.
Or sorry, I.
Oh, my bad.
Right? No. I'm really glad you said that because yeah, hotels give out complimentary stuff. Now, just so you know, nothing is free, Luke. When your hotel gives you complimentary stuff, it's because you're overpaying for the room, and they want you to feel like you're getting something for free. But okay, John, go.
Well, like milk and cereal complement each other.
Ooh. Yeah, I mean, have you ever guys have heard of peas and carrots?
Mm-hmm.
Don't peas and carrots go together really well? Okay, it's actually a phrase. There was a very special movie many years ago called Forrest Gump. And in the movie Forrest Gump,
Oh, I've seen that.
Forrest says about his girlfriend or his wife, Jenny and I, we're just like peas and carrots. So we go together really well. Now, guess what else is complimentary? You ready for this? a 40-degree angle and a what are complementary? What do you think, Hannah?
A 60-degree angle.
Really, really close. Awesome,
50?
awesome conjecture.
20-degree angle.
David?
A 50-degree, because they make a 90-degree angle.
Yes. So everybody go like this. Everybody make that 90-degree angle with their hand, okay? Any two angles that add up to 90 degrees are considered complementary. So 40 and 50 are complementary. What about 30%? What do you think is the complement to 30%? I'm going to go with John.
70%.
Nice. Now, Claire, can you give me another example of something that would be complementary?
A 40-degree angle, 40% and 60%.
I love it. I love it. 40 and 60%. Now, what about numbers in and of themselves? The number, I don't know. Oh, David?
Maybe 1 and 9, because they make 10.
9 and 1 are complementary because they make 10. What about 90? Cameron?
10.
Very nice. Whoever called out 10, please don't do that. Cameron, what is the power of 10 to which 90 and 10 are complementary?
9.
The power of 10 to which 9 and 1 were complementary was 10.
Oh. Yeah.
What is the power of 10 to which 90 and 10 are complementary? Look at the screen, it might be helpful. Answer?
100.
100. Very, very good. What about 90? Wait, how about 2 and what? Go, say it out loud, everybody.
8.
And then what
8.
about 8 and,
2.
okay.
98.
What about 99?
1.
1.
And what about 1?
99.
You
Or
fell
9.
into the trap.
9.
9.
It's 9. So everybody falls into that trap. It's all about the next power of 10. What about 720? Don't say it out loud. Write it down. Don't just write down the complement. Write down the number, the complement, and the power of 10. All right, on 3. 1, 2, 3.
80.
280.
And the next power of 10 is?
1,000. 1,000.
So do you guys see the pattern here? Now, I'm going to throw out a challenge. What about 10?
90.
90. Very good. Because the next power of 10 after 10 is 100. What about, let's see. What about 3/7?
4 sevenths.
4 sevenths.
1.
4/7.
Can you explain, please? Can somebody explain that? David?
Because 10 to the 0th is 1. And
So,
that would be
guys, do you see that 1 is also a power of 10? And 3/7 and 4/7 is? And by the way, do you remember when we were talking about 40, when Claire brought up 40% and 60%? Isn't that the same as 2/5 and?
3/5.
3/5.
That is the same thing as saying 60% and 40%. So I love thinking of things that are complementary. They're a lot of fun. Now, there's another concept called complementary pairs. Now, complementary pairs are different. They are not complementary numbers. Complementary pairs are different. So for instance, the complementary pair must be a 2-digit number or more. So the number 38 has a complementary pair of 32. The number 14 has a complementary pair of 16. The number 203 has a complementary pair of anybody?
207.
Wow. So who can articulate the rule for complementary pair? I'm going to start with you, Luca.
So it has to be more than 2 digits, a 2-digit number, as you said, or more. And it has to have the same fourth digit, same number for the fourth digit.
But is that true
the
for?
first one or more digits.
Okay.
And then the last digit has to be add up to 10 or 100.
So can we say that the ones digit is a complementary number that are complementary numbers, right? The ones digit are complementary numbers. Does that make sense?
Mm.
Okay, so I want everybody right now to come up with a number and give me the complementary pair. Okay? And it can be any number of digits, but don't go crazy. Like stay within like the 2 or 3 digit range, please. So I'm going to have you give me a number, and then I'm going to have you give me the complementary pair, and then we're going to do some really cool stuff with it. Okay, we're going to start out with you, Hannah.
44 and 46.
Okay, John.
408 and 402.
Beautiful. Cameron.
309 and then 301.
And Claire.
61 and 69.
I love it. And Rafa.
132 and 138.
And Isabella.
87 and 83.
And David.
67 and 63.
And Luke.
806 and 804.
Perfect. And Alexander, and then Luca. Alexander, please. Alexander, can you hear us? Give me a thumbs up if you can hear us. Oh, I don't think Alexander can hear us. Okay, Luca.
726, 724.
And Alexander, we're going to start one more time. Alexander, can you hear us?
What?
Can you hear us?
Yes, now I can.
Okay, great. Alexander, can you give us yours? And turn up your volume, Alexander. Alexander, come on, buddy. Everybody's given us a number and a complementary pair. Isabella, did you give us yours? Okay, cool. Alexander, we're waiting, buddy.
704 and 706.
That's perfect. Okay, now, would you guys like to see something cool?
Yes.
I'm going to teach you how to multiply those numbers in a few seconds. Okay? There's a really cool algorithm that I was playing with, and I think it works. Let's actually not do that one. Yeah. Let's do that one. Let's do
Tape diagram.
Let's do this one. Okay, are you guys ready? What I'm going to do is I'm actually going to write out the answer, and I want to see if you could come up with the algorithm. The first thing I'm going to do in the second two digits is I'm going to write out 24, 16, and 09. Can anybody tell me where I got 24, 16, and 09? Yes. Claire?
You multiplied the ones place?
Does everybody agree that 4 times 6 and 8 times 2 and 9 times 1 is 24, 16, and 09 respectively?
Yeah.
Is that a yes?
Yes.
Okay, Claire, nice work. Now, the next one's a little bit harder, so pay attention, please. And then guys, if you want, you can even check those out in your calculator. So 44 times 46, 408 times 402, 309 times 301. Are my solutions correct? And can you figure out where I got the first numbers from? And don't do any others on the calc, please. So, Hannah, what's your thinking on this?
I think because for the first one, the tens digit numbers are 4 and 4, and 4 times 4 is 16, and then 16 plus 4 is 20.
Keep going.
Then for the next one, it's 4 times 4 is 16. And then for this one, you added on 40, maybe because it's a 3-digit number rather than a 2-digit number. And then for the next one, you again added on 30 to the product of the 100-digit number.
I like it. In fact, there's 2 ways to look at this group right here. And I'm going to talk about that in a minute. Can anybody else give me a different explanation? Because I love Hannah's explanation, but I'm looking for something else that might make it easier for you guys to execute the rest of these. Cameron, you had an idea? Alexander, you're thinking about this? Okay. I'm looking for everybody who has an idea. Rafa, are you thinking about this?
Yeah, I'm a little confused about the algorithm, but I'm trying to read this.
Good. That's my man. Luke, what about you?
Well, I mean, I was thinking in my head, it was very similar to hers. It was basically like for the 309 and 301, it was it was 30 times 30 plus 30.
I totally agree. Let's do this, guys. let's send this to another page, all right? I want you guys to watch this. Hannah said, take the 4 and let that be our x value. She then squared it, 4 times 4, and then she added 4 to that. Would you agree that that works for all of these? Now, another way to think about this is, why not just take 4 and multiply it by the next integer, which is 5. So 4 times 5 is
20.
20. 40 times 41 is 1640. Come on, what times what is 930?
30 times 31.
31.
Wow.
And guys, how can Hannah be right and Mr. Kramer be right at the same time? That's what's puzzling me a little bit. Hannah said that it was x squared plus x. Kramer said it was x times the quantity of x plus 1. Can anybody tell me algebraically what's going on here? Oh, and by the way, if any of you are distributive property freaks like me, make your little rainbows. Guys, what is x times x?
X squared. Squared.
What is x times 1?
X. X.
And if you add those, it's the same thing. So the reason why Hannah was correct with her algorithm and Kramer was correct with mine is because they're the same algorithm, just 2 different ways to do it. Now, let's do one more together. Let's do the 61 and 69. I think that might have been Claire's. Come on, guys, what's the last 2 digits?
9.
9.
It has to be 09.
09 and then.
And what are the first 2 digits?
6, 7
30.
times 7.
Guys,
Oh, wait,
6
no.
times 7
And
42.
42.
is 42. Put it in your calculator. 61 times 69, does it equal 4,209? Now, you are not allowed to do these on your calculator. But what I want you to do is use the algorithm and then check them with the calculator. All right, get started.
The ones that are on screen now.
Yep. And you don't have to make the boxes if you just want to write down the answers.
They're just ours.
And get working, guys. And Alexander, I can only see the top of your head. You're the only one that is not centered in the screen. Angle your computer down so you don't have to sit up. If you want to slouch, go slouch. Just angle the computer down. It's just hard talking to a forehead, especially a nice forehead, but you know, there it is. By the way, that was a compliment with an I.
Are videos off allowed?
Yes, they are, but you have to turn your volume up.
Okay, so I can have my unmuted, but I'll just have my
Yeah,
video
you know,
off.
I would appreciate the video on unless you have an objection to the video on, because it's just harder for Mr. Kramer. It's harder for me.
Okay.
But if you have an objection to the video, then absolutely turn it off. But you have to leave it off the whole time. Okay, you can't just come in and out. It's just too hard to manage. And if anyone has a specific question, this would be a really good time to ask it. Like as you're doing it, if you want help doing a particular calculation. And after we're done with this in about 5-10 minutes or so, we're going to do some huge complementary pairs. Like we're talking massive numbers. I hear some clicking, which means someone is checking their work on their calculator, which is perfectly okay. You just can't do the problem on your calc.
Yeah, that was me. I was just.
And that's okay, dude. You're allowed to do that. I want you to do that.
I was just checking mine.
Okay, well, I finished. Oh wait, I still have to check.
And if you finish them, by all means, create other ones on your own.
So if we want to like a quiz or anything, if we notice like somehow notice that one of them's complementary pair, we can just use this and solve it way quicker.
Oh, yes, definitely. It's really, I have developed many algorithms for things like this, and I don't know why. This one I tried to solve it algebraically, and I had a little trouble, Luca. I had a little trouble trying to prove it algebraically and why it works. But there's other ones where I was able to prove them algebraically. Okay, may I give you guys a pause for a moment? And I'm going to ask 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Who wants to answer the first one? John, I'm going to let you answer the first one. Go for it.
182,016.
And John, did you do 13 times 13 plus 13? Like 169 plus 13 is 182. That would have been a cool way. Or did you just go 13 times 14?
I did 13 times 14.
All right, beautiful. Hannah, I'm starting to think I like Hannah's method even better than my own, but it's kind of cool. Who's going to do 87 times 83? David?
I got 7,221.
Perfecto. Who's going to do 67 times 63? Rafa? You'll have to unmute yourself.
4,221.
Amazing. Who's gonna do the next one? Oh my God, the next one's hard. 806 times 804. And I've got 2 hands up. Anybody else wanna share that one? I've got, now David, Rafa, and Craig have, and John have already answered. I'm curious as to anybody else who came up with this one.
I really want to do mine though.
Well, which one did you do?
726 times 724.
And what'd you get?
Before ever. 5,256. 24. And then
Ah, did you mean to say 525,624?
Yeah.
Very, very nice. Hannah, do you want to give us 806 times 804?
I got 648,024.
Same.
How's that looking, John, Rafa, and David? Same thing you had?
I got 648,000.
Same.
Okay,
That's
guys,
what
everybody watch this. 81 times 80, watch how I do it, is 864. And so what I would get is 648,024.
Yeah, that's what
That's what I got.
Okay, so Hannah,
Actually,
do you see?
I actually did get that. I read it wrong. I thought my
Oh,
8 was a
beautiful,
0.
beautiful. Oh, honey, I'm so happy. I'm so happy. Who did the 704 times 706? Who did that one? I'm looking for Cameron.
I got 27,224.
that is
Uh,
not what I got.
if I got 71 times 70, Cameron, which is 4970,
Oh, I just
what do I want to tack on to 4970? The 4 times 6, Cameron?
24.
And 24 is correct. So Cameron, does it make sense when we did 70 times 71? Yes? Okay, now I want to show you guys an interesting algorithm here. Are you ready? So we have, how about let's try 2. So 10,002 times 10,000 what?
10,000.
Now, don't we have to do 1,001 times 1,000?
Yeah.
I do 11 times 10.
Now, hold on a second. Does everybody see that we have to do 1,000 times the next integer? Yes?
Yes.
Do you guys see that I wrote the 1 for the 1,000 below the ones column of the 1,001?
Oh, do you write it like, do you just shift stuff down?
I shift all my zeros out of my region. I do not focus on these zeros at all. I don't cross them out, but I put them outside. Now, are you guys ready? 1 times 1, 1 times 0, 1 times 0, 1 times 1.
1,001.
And then, you want to bring down these zeros now?
6,060.
So, did you guys get 1,001,000?
Yeah.
Anybody have a question about how I got that?
But don't you still need to do the 16?
Yeah.
No, don't. I'm not there yet. Luca, I just want to make sure that everybody gets this algorithm.
I got that one.
Question, is everybody there? Are you
Yep.
sure? If you're not there, you've got to raise your hand right now. Okay, now guys, watch this. 1001 followed by 3 zeros followed by what?
16.
Now, everybody put this in your calculator. 10,002 times 10,008. I'm going to do the same thing. So 10,002 times 10,008. Did you guys get it?
Yep.
Now, because you are able to do that, I am now going to throw at you
Oh, God.
go for it. And once you do that, I want you to check it on your calculator and then do others, which are massively challenging.
It's a big number.
Got it.
Wow, cool.
Ooh, that is huge.
Yeah, and check it with the calculator. Some calculators won't even go that high in terms of digits.
Oh, mine's online, so it can go so high.
Really? How many digits, Luca?
A
Mine
lot.
can,
I just use a Google calculator. and
yeah, it can go like 20 digits. It's a
Really?
big calculator.
Yeah, I gotta check out my iPhone calc.
Time's not coming.
Just go to Google and search up calculator, and it's on a computer, it's pretty big.
Go in search of calculator and then you can.
Oh wow,
Now just check this.
that is a lot.
So 15. Interesting. So the Apple guys, the Apple goes 16 digits.
I'm gonna see how big this one, the Google Calendar, goes.
And I'm gonna start
Oh,
writing out my
yeah.
solution, guys, for this.
I missed a zero when typing it in.
That will definitely make a difference.
Oops.
How many of you got the number that's at the bottom of my screen?
Yeah.
Did you get it?
Yep,
Wait, no, you
got
you
that.
haven't added a zero.
Did I miss a zero?
No, you added a zero. You said 2 with 4 zeros. And I
Two,
believe it's supposed to be 2 with 3
4
zeros in the middle.
zeros.
On the top.
On the top.
Like on the top when you're doing the equation.
Yeah.
You had 1 extra zero.
Uh,
Because it minus the zero, adding the 1.
Things in the wrong
I
place.
think you
Got
did
that
great.
exact thing.
did anybody else get something different?
You know what? I got what you got.
I had another 0 in between the 2 and 25.
Between the 2 and, oh, you did. But I think though that I'm going to object to that.
Yeah, I see what
because
I did wrong.
It's 20,000
Yep.
and 20,000.
Yep.
And those are the number of tens. So I think I'm going to go with my 400, what is it? 400 billion?
Billion.
2
It's a big
million
Billion.
25. Now, just to show you guys, this is very unsatisfying. my calculator here gives this to me in scientific notation, and I can't even tell. I mean, I know it's right, that our work is right, but that calculator doesn't really do it for me. So, yes.
Mr. Kramer, the Google calculator, it actually goes on for a very long time because after you fill up the space, it actually keeps going.
It keeps going, and you can't even see the numbers sometimes. It just keeps going until
it just gives up.
Yeah.
Wow, that's pretty cool. That's very cool. Now, are you guys ready for another big challenge?
No.
What do you guys think? Should we do
All
it?
right, let's
All right.
do.
How about
One, two, three, four, five, 6 times 7, 8. Oh, what? I thought it was.
Does
gonna
it
be
add up
7, 8,
to
9,
10
10.
though?
2, 3, 4.
So do you see what I've done?
Yeah, you're doing.
You know that 6 and 4 are complementary numbers.
But 4 and 4 and 3 and 3 and 2 and 2 and 1 and 1.
Yeah, but remember, now we have to take the number
Oh God.
and we have to multiply that number by the next integer.
Oh wait, this actually isn't too hard.
Now, if you have trouble with your standard algorithm, you might want to watch me do this. If you'd want to try it on your own, then don't look at my screen. All right, but I'll work it and then you guys can follow.
I think I got it.
What I'm doing.
Maybe. I'm not sure if I'm right. No, I'm not. Yeah, I'm just gonna have to do.
Mr. Kramer, I think on your algorithm, the bottom number, you have a 6, when in the equation it's a 5.
Yeah,
Say
you're
that one more time, honey.
your last digit.
The second number in the equation it would be 1, 2, 3, 4, 5. And in the equation you wrote 1, 2, 3, 4, 6.
Yeah. Because there's a 5 in.
Oh,
That's because you have to multiply it by the next integer.
Yes, yes, yes. So Claire, what I did is I looked at the 12,345. Do you see how the 12,345, right?
Yeah.
And then I had to multiply that by the next integer. Does that make sense, Claire? Okay, but I'm really glad that you pointed it out. It's really important that you did that.
How you do this? Oh, I know what you're doing.
And if you have a question, this is a really good time to ask it. By the way, do you notice how I moved my problem all the way over to the right now?
Why is there a smiley face?
Oh, because I do that for my placeholders. It's my own little method because people get these confused with zeros all the time.
Can I try it? Can I just test it? I didn't do this same way you did. But can I try if mine's
Oh
right?
yeah, try it. Try it your own way.
Oh.
I'm all about best practices and better practices. You find a better way, that's my new best practice.
Oh wait.
If we think what we have is the answer, can we check it?
Oh, you betcha. You betcha.
I was very off.
Me too.
Whoa. Like 1 million off.
Off.
Oh.
Oh, I actually. No, I didn't.
I think
It was off.
what number you're writing down is off of mine.
So off. I was so off.
It's not easy, guys, to keep all these numbers and track them.
I got, oh, yay. I was off, but then the calculator corrected me.
Wow. That's like.
Say the number.
So I got what I think might be the answer, but now I have to, of course,
Google says your answer is correct.
Yeah.
really?
You got it right.
It was very, 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 very off from that.
15,241,137,024.
That's
Wow.
very
Yeah.
off from what I heard.
Guys, I have to tell you, this has been an amazing class. It's a great way to end a beautiful week for me. I just have 2 more hours and then I'm off tomorrow, back on Friday. I hope you guys have a great Thanksgiving, and please say goodbye to all of your beautiful mathematician friends. By the way, Rafa, what is that little bear thing? That's kind of cool. I like that. Can I see it? Wow. He's huge.
Yeah.
He's
Well,
huge.
it's called Real Akuma.
What does that mean?
I don't know. It's Japanese. That's all I know.
Oh,
Google
is he really,
Translate.
is he really comfortable?
Yeah.
All right, great. Hey
I just-
guys, please listen to your turkeys. They know what they're talking about. I say double double to you and have a great Thanksgiving.
Happy
Have a nice day,
Thanksgiving.
Happy Thanksgiving.
Happy Thanksgiving.
Happy
Bye.
Thanksgiving.
Happy